Hello, this video is for pre-algebra. I'm Mrs. Rodriguez. This is for chapter 5, lesson 5, all about solving multi-step equations and inequalities. So I'm just going to go over a few examples. Hopefully this will be helpful to you. Okay, I'm going to go ahead and share my screen. All right, so like I said, lesson 5.5, solving multi-step equations and inequalities, okay? So first, it says to solve each equation and check your solution, okay? So at this point, you should understand what an equation is and that you have to keep equations balanced. Whatever you do to one side of an equation, you have to do to the other side. So here, I have a 4 outside a set of parentheses, but there's no operation symbol between. So I'm going to apply the distributive property. That means to multiply. So I have to multiply the 4 times the j and times this -7, okay? So when I do that, I end up with 4j minus 28 is equal to 12, okay? Then I have a two-step equation, okay? So it says minus 28, so I do the inverse. I'm going to add 28 to both sides. Remember, I got to keep my equation balanced, okay? So that equal sign is kind of like a line, a wall there. Whatever you do to one side, you have to do to the other. So negative 28 plus 28, well, that's 0, so that's gone. But I still have 4j, and then 12 plus 28 is going to give me 40. Now I divide both sides by 4 because right now j is being multiplied by 4. So I do the inverse and I divide both sides by 4 and j ends up being 10. Now I'm saying that this is my answer. It says to check your solution. So the good thing about equations, you can always double check to see if you're correct. So you plug in your answer into the original equation. So 4 and in parentheses j minus 7. So instead of j, I'm going to put 10 minus 7, and I should get 12. If I get 12, then I know I'm 100% correct. So now I need to follow order of operations. So I do what's inside the parentheses first. So that's 10 minus 7, which is 3. I'll keep that in parentheses. I still have that 4 outside my parentheses, so I'm going to multiply. There's no operation symbol here. So this is 4 times 3 is 12, and 12 is equal to 12. So I know that I'm correct, okay? So let's look at another problem here. So very similar problem, it just has a few more steps, okay? So I have a 7 outside my parentheses. So again, I need to distribute and multiply the 7 times both terms in the parentheses. So 7 times 2p, that's 14p, and 7 times 3 is 21, and then I still have this minus 8 equals 6p plus 29, okay? So at this point, I can do a couple of things. I can combine these like terms, or I can get the variables on the same side. Either way, as long as I do both of them, both steps to both sides of my equation, then I'm still going to get the same solution, okay? So let's say I combine these like terms, 21 minus 8. So I still have my 14p, and then 21 minus 8 is going to give me 13, and that's a positive 13. And then I still have this 6p plus 29. Now I have variables on both sides of my equation. I just want them on one side. So I can either subtract 14p from both sides, okay? But if I do that, I'm going to end up with a negative over here. So I could also subtract 6p from both sides, and I would end up with a positive over here. So I think I'm going to do that instead. So 14p minus 6p, that's going to be 8p. And I still have this plus 13. This 6p minus 6p is 0, and then I still have 29, okay? Well, now I have a two-step equation. So I need to get rid of this plus 13. So I do the inverse. I subtract 13, and I end up getting 8p is equal to 16. Now I have a one-step equation. 8 times p is 16, so I do the inverse. and divide both sides by 8, and p is equal to 2. Now again, I can check this. I'm going to put a 2 in parentheses every time there's a p in the original equation. So minus 8 equals 6 times 2 plus 29. So I'm going to follow order of operations to solve this. So this is 4. 2 times 2 is 4. And then I still have the plus 3 and the minus 8 over here. I can do 6 times 2 is 12 plus 29. Now again, I'm going to do what's in the parentheses first. So that's 4 plus 3 is 7. I still have that 7 outside, and this minus 8. And then 12 and 29 is 41. And then I'm going to multiply first. 7 times 7 is 49 minus 8. And 49 minus 8 is 41. 41 is equal to 41. So I know I'm 100% correct on that one. Okay. Now, this one just makes it a little more challenging because it's got some decimals in there. Okay. Now here I have variables on both sides, and d is being divided by 2/10. So what I want to do is undo this dividing by 2/10 by multiplying both sides of the equation by 2/10. Okay. Now when I do that, that will cancel that out, and I get d equals, now I've got to multiply 2/10 times 3d and also times 2.1. So when I multiply 3 times 2/10, I end up with 6/10 d plus 2.1 times 2/10 ends up being 42 hundredths. Okay, so now I have variables on both sides. So remember right here, this d, there's a 1 in front of that d. So I'm going to subtract 6/10 from both 6/10 d from both sides because I want my variable to stay positive. So 1 minus 6/10 is going to give me 4/10 d. This is 0, and then so I still have that 42 hundredths over here. So then I divide both sides by 4/10, and then 42 hundredths divided by 4/10 is equal to 1 and 5/100. Okay. And I could plug this in and see if it is correct. Okay. So I strongly recommend that you do that on your tests. Each one of those types of problems, you can double check your solution. Okay, now the second half talks about inequalities, okay? And it says to graph the solution on a number line. Now, the difference between an equation and an inequality is that when you have an equation, there is one possible solution, okay? For each one of the previous problems we just did, there was only one possible answer that would make that equation true. Now, when you're talking about inequalities, there are an infinite number of solutions that would make an inequality true. Okay, that's why you have to graph your solutions on a number line. For example, if you end up with some kind of solution where x was greater than 12, okay, so that means x can be 13, 14, 15, 15.2, 15.3, 15.4. It can be any value as long as it's greater than 12. It cannot be equal to 12, but it can be greater than 12. So we obviously cannot list every possible solution to that inequality, so we use a number line to represent that, okay? However, inequalities are solved just like you would an equation, okay? So let's look at with one major difference, which I'll get to, okay? So if we've got 2/3 times, in parentheses, 12 minus x is greater than 4, okay? So I'm going to distribute 2/3 times 12 and times negative x, okay? So I do 2/3 times 12. I can cross simplify here. This ends up being 8/1, which is 8, okay? So I have 8 minus 2/3 x, okay, is greater than 4, okay? So now I have a two-step equation. I have this 8, I can get rid of it by subtracting 8 from both sides, and then I've got negative 2/3 x is greater than 4 minus 8 is going to be negative 4, okay? Now x is being multiplied by negative 2/3. So I want to do the inverse, and I want to divide by negative 2/3, right? So negative 4 divided by negative 2/3. So these would cancel, and this would be x, and then negative 4 over 1 divided by negative 2/3. Remember, you keep the first fraction, you flip the second, and then change division to multiplication. Okay, I can cross simplify here. 2 goes into 2 once and also goes into 4 twice. Okay, so this would be negative 2 times negative 3, which is going to be positive 6 over 1, which is just 6. Okay, so now the big difference between solving an equation and solving an inequality is that if you multiply or divide both sides of your inequality, you have to flip the direction of the inequality, okay, in order for it to be true. So right now it says greater than, but I multiplied by a negative 2/3, so I'm going to flip that. Okay, so x has to be less than 6. So it could be 5, it could be 4, 3, 2, 1, 0, negative 1, negative 2, any number that's less than 6. So that means at 6, I'm going to put an open circle because it cannot equal 6. If it was less than or equal to, then I would color this in. But it has to be less than 6. It cannot be 6. And then everything to the left, or everything that's less than, I'm going to shade that in. So anything here is a possible solution, okay? All the way to negative infinity, okay? All right, so let's go ahead and look at another one. Now here we have c over 3 plus 7 is greater than 5 and 1/2, okay? All right, so again, I have the variable being divided by a number by 3, so I'm going to multiply both sides of my equation by 3. So I end up with c plus 7 is greater than, I don't flip it because I multiplied by a positive number, so I have to multiply 5 and 1/2 times 3. So this is a mixed number, so I'm going to make that an improper fraction, and then put that 3 over 1, okay? So I end up with 33 over 2, okay? And then I need to subtract 7 from both sides, and I have c is greater than. Now again, I don't flip anything because I'm subtracting 7. I'm not multiplying or dividing by a negative. So now I have 33 over 2 minus 7 over 1. I want my denominator to be 2, so I multiply. So that would be 33 over 2. Denominator stays the same. So that would be 19 over 2. 19 over 2. And if I change that or rewrite that in as a mixed number, 2 can go into 19 just a second. Okay, so I made a mistake on that problem. So let me go ahead and clear this. All right, so I'm going to clear that off. Hopefully. Okay, hold on a second. All right, sorry about that. Let me go ahead and share that screen again. Okay, so for this problem, for this inequality, first thing, c over 3 plus 7 is greater than 5.5. Okay, so first thing I'm going to do is subtract 7 from both sides. That's what I didn't do before. I tried to multiply by 3, but I should get rid of this 7 first. Okay, so this is c over 3 is greater than, when I subtract, this ends up being 11 over 2, and this is 14 over 2. So 11 minus 14 is negative 3, and my denominator is still 2. Okay? Then c is being divided by 3, so I do the inverse and multiply both sides by 3. I end up with c. I do not flip the inequality because I multiplied by a positive number. And then negative 3 times 3 is negative 9. And then 2 times 1 is 2. So c is greater than negative 4.5. Okay, so when I graph that, I would put an open circle at 4.5, and then I would shade everything to the right, everything greater than, okay? All right, sorry about doing that one incorrectly the first time. Okay, so I believe this is the last problem. So here, going to apply the distributive property. Okay, so this ends up being negative 3x, and this is negative times positive 3, so that's negative 9, is greater than 7.5. Okay, so I'm going to add 9 to both sides, and I end up with negative 3x is greater than, this would be 16.5. Okay, now I'm dividing by a negative 3. So that means I'm going to flip the direction of my inequality. Okay, so now I'm going to say x is less than, and when I divide 16 and 5/10 by negative 3, I end up with negative 5.5. So when I graph that, negative 5.5 is going to be here, and this is an open circle because it's less than. X is less than negative 5.5. So everything to the left is going to be shaded. Okay. All right, so I hope this video was helpful. If you have any additional questions, please call, text, email, or stop by my office hours, and I'll be happy to help you. Office hours are Mondays and Wednesdays from 2 to 3, and Tuesdays and Thursday mornings from 9 to 10, and there's the link to my office hours, okay? Hope you have a great day.